Next is problem number 17. Here we have a list of jobs and two workstations, and the processing time for the two workstations are given. Now we are supposed to come up with a schedule and a Gantt chart that will minimize the make span. And we're going to use the Johnson's rule. The Johnson's rule states that you select the smallest processing time job and then place it earliest if the smallest time is for the first workstation and latest if it is for the second workstation. So the smallest among all the numbers is this, so we select E, and since it is for the second workstation, we place it at the last position. So now we are done with E, and from the remaining, the least processing time is 18 for B. So now we have to place B, since it is for the first workstation, at the earliest spot. Okay, so now B is done. Now we need to look at the remaining ones, and here 24 is the smallest, and that's for the second workstation. So we place it right before E, the last possible position. So now D is done. From the remaining, once again, we select the smallest one, which is that, and that is for the first workstation. So you place it at the earliest possible position, and that leaves C, so that goes there. So this is our Johnson's rule schedule. Schedule by Johnson's rule. Okay, so now we have to come up with the Gantt chart, and the Gantt chart will give us the actual make span. We need to carefully set up our x-axis. So let's do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 40, 50, 160, 170, and 180. Okay, so now we need one bar for the first workstation, so this is workstation 101, and then we need a second one for the second workstation. So now we need to schedule the jobs. Okay, and the job order is here. Okay, and we'll have to schedule them one by one. Okay, so we'll schedule the first workstation first, and there is no idle time there, so we can just go ahead and schedule them according to this. So first one is 27, First one is B. B is 18. So we have to schedule B for 18. So 18 will be approximately, so here 15, so approximately. So that would be our B. And that is 18 days. Next is A. Now A is going to, so B is 18. A is 27, so it's going to end at 45. So 45 is here. So A added 27. So A is going to begin at 18 and finish at 18 plus 27, 45. So next is C. Okay, C processing time is 70. So 70, if you add to 45, that will take us all the way up to 115. So 115 is, so here 110, so right there. Okay, so that is C of 70 will take us up to 115. And after C is D. D takes 26 days, so that 26 days will take us up to 141. Okay, so 141 is just a little bit to the right side of 140, so that's 141. D taking 26 days. And then finally E, and E requires 15. So if you add 15 to 141, that will take us to 156. So that will be about that. So at 156, the first machine will finish all the jobs. Okay. So now we have to schedule all of these jobs in the second workstation. Okay, now right off the bat, we have idle time of 18. So the first 18, because there's no job that will be ready to be taken up, so this is our idle, the first one. Then right at 18, so this will be at 18, B can be scheduled in the second workstation, and B requires 33, so at 51 B will be done. So 51. So you start at 18 plus 33 will give you 51. Okay. So now when B is done, now A is the next job, and A is already done with the first workstation at 45 and it is waiting. So right at 51, A can be loaded in the second machine, and A requires 45 in the second machine. So that will take us all the way up to 96. So 96 is like that. So A requiring 45, and that is 96. So 96A is done, and the next job is C, but C is not done in the first workstation. C will be done only at 115. So until that time, the second workstation will have to idle and wait for C to get finished in the first workstation. So this will be idle time in the second workstation. Then C will be loaded, and C requires 30 days or 30 hours, whatever the time unit is. So it will get loaded at 115, and plus 30 will be done at 145. So that is C of 30, so it will be done at 1:45. Okay, next is D. Now C will be done at 1:45 and it will be ready for the next job. The next job's D will be ready at 1:41 and it's waiting. So D can be immediately loaded on the second machine at 1:45, and D requires 24, so it will be done at 1:69. So 1:69 it will be done. So that's 1:69. So D requiring 24. Now at that time, E is already done. E is done at 1:56 in the first machine. So E is just waiting and it can be immediately loaded. So there is no idle time at this point. So E requires 10. So at 1:79 it will be done. So 1:79. So the make span, okay, so that is that 1:79 it is done. So the make span is 1:79. Okay. Now the last question is, if we are allowed, so these are in minutes, so these are all in minutes. If you are allowed to split the jobs and how much of the idle time we can save. So idle time, the first idle time, okay, for B is 18. So 50% of 18 is 9. Then we have idle time for C. For C, and the idle time is how much? Okay, so this idle time is 19. Okay, that minus that. So the idle time is 19. So this can be split 60%. So 60% of 19 is 11.4. Okay, so the total idle time is 37, and can be saved by splitting is 20.4.